Hello students, a very good morning. So, in this today's class, let us solve one more problem. It is given, calculate E cell and Kc, that is the equilibrium constant Kc for the reaction Mg, where Mg2 plus the concentration of the electrolyte is 0.001 molar, and Cu2 plus where the concentration is 0.0001 molar. Okay, so this is a cell they have given, and the standard electrode potentials of the two electrodes, one is a copper as well as a magnesium electrode is given. The value is given. For copper it is 0.34 volt and for magnesium it is minus 2.37 volt. Now we have to calculate E cell. So what is the formula? So E cell, so let us write E cell or a cell potential which is equal to E naught cell, isn't it, minus 0.059 divided by n. Instead of writing 0.059, you can also write like this, 2.303 RT divided by n into F. So by substituting all the constant values, I written 0.059 divided by n, where n is the number of electrons involved in the electrode reaction, S. Okay, log, in the numerator what we have to write? Oxidized species. Look at the cell, in a given cell, the left hand electrode is anode, I already told. So the left hand electrode, nothing but anode, it is always written on the left hand side, whereas in the right hand we have a cathode where it is copper electrode. Now, so in the left hand electrode, that is the anode, at the anode always oxidation occurs, isn't it? So what happens here? Magnesium, it undergo oxidation, it will form Mg2 plus. So in the numerator we have to write Mg2 plus, the oxidized form of the species, divided by reduced form of the species, that is Cu2 plus. So this is the formula we have to use here. Now, in order to calculate the E cell, we need E naught cell, the standard EMF of the cell. So whether the value is given, no, that we have to find out. So here they have given the copper electrode potential 0.34 volt, and for magnesium electrode potential is minus 2.37 volt. So now let us find out E naught cell first. E naught cell is equal to, what is the formula? It is standard electrode potential of right hand electrode and the difference in the electrode potentials of right hand electrode and the left hand electrode. Okay, so now which is the right hand electrode in the cell? See, I have given one trick. This is A, this is B, this is C. What is A? Stands for anode, B is salt bridge, C is for cathode. So right hand electrode, it is always cathode. So what is its electrode potential value? It is 0.34 minus left hand electrode is anode, it has electrode potential is minus 2.37 volts. So which is equal to 0.34 minus of minus plus 2.37. So which is equal to how much? It is 2.71 volt. That is a standard electrode potential, E naught cell. Okay, now we can substitute E cell, which is equal to E naught cell, it is 2.71 minus 0.059 divided by n. The number of electrons are transferred is 2 Mg2, magnesium to magnesium 2 plus, that means there are 2 electron difference, log of, what is the concentration of Mg2 plus ion? It is 0.0001 divided by, what is the concentration of Cu2 plus ion? It is 0.0001. Okay, so now you can solve So here the cell potential value, so we'll get the answer is, try to solve this. So the answer is 2.68 volt. Here answer is 2.67 volt, that is the cell potential. Okay, that is the first question. Next we have to find out what? Equilibrium constant, Kc. So calculate the equilibrium constant. We have the formula, isn't it? So E naught cell is equal to, so we have E naught cell is equal to 0.059 divided by n log of Kc. So this is a relationship between E naught cell and equilibrium constant. So now we can substitute the values here. E naught cell, it is 2. Okay, sorry, it is not E cell. So it is E naught cell. What is the value? 2.71, 0.059 divided by 2 log Kc. So log Kc, calculate the answer here, log Kc. Then let us find out Kc. So equilibrium constant, it is anti-log of the answer, this answer. So which is equal to, I'll directly write the answer. So you can solve this, isn't it? The answer is 7.31 into 10 to the power 91. So 7.31 into 10 to the power 91. It is a equilibrium constant for this particular reaction. Okay, so this is about problem, very important type of problem. Okay, next. So after this, let us discuss one more topic. Conductance of electrolytic solution. So conductance of electrolytic solution. Okay. Conductance of electrolytic solution. So what is this conductance in case of electrolytic solution? Okay, so before going to the concept, let us define conductors as well as insulators. So some substances can be classified into conductors as well as insulators. So what are the conductors? What are conductors? So conductors are the substances which allow the current to pass through it, whereas insulators are the substances which do not allow the electricity to pass through it. So conductors are the substances, it can conduct electricity, it can conduct what? Electricity. Example for conductors, any metals and even alloys can conduct electricity, whereas insulators, these are the substances which do not conduct an electricity. Okay, now under conductors we have two types. Okay, so under conductors again there are two types. One is electrolytic conductors, and one more is electronic, or it is also known as metallic conductors. Okay, so what is this electrolytic conductors and electronic conductors? Electrolytic, here these are the conductors which allow the electricity or a current to pass through it due to the flow of ions. It may be cations or anions. Because of the movement of ions, this particular conductors can conduct electricity. Okay, so the electrolytic means these are the conductors which allow the electricity or a current to pass through it because of the movement of ions in it. Whereas electronic or a metallic conductors, the name itself indicates metals. Metals, they can conduct current, they can conduct electricity mainly because of the flow of electrons in it. So the electronic or a metallic conductors are the conductors. It conducts electricity mainly due to the movement of or a flow of electrons. Clear? Now, so here under electrolytic conductors, the electrolytes, they can be classified once again into strong electrolytes as well as weak electrolytes. So, under electrolytes, we have strong electrolyte and weak electrolyte. Okay, strong electrolytes and weak electrolytes. So strong electrolytes are the substances it will undergo complete dissociation or complete ionization. See, if you consider a strong acids or strong bases. For example, HCl. So what happens? Hydrochloric acid or HCl, it undergo complete dissociation and it produces ions, H plus and Cl minus ions. Similarly, strong bases like potassium hydroxide, sodium hydroxide, they undergo complete dissociation to produce us what? Ions. So strong electrolytes are the substances, electrolytes in the sense they must conduct electricity, whereas non-electrolytes, they do not conduct any electricity. So under electrolytes we have strong electrolytes and we have weak electrolytes. So strong electrolytes, it undergo complete dissociation. So that means this type of electrolytes, it conduct electricity to a maximum extent or to a maximum extent. Why to a maximum extent? Because since it undergoes complete dissociation, as a result the ions obtained is more. Okay, next is the weak electrolyte. Weak electrolyte, it will undergo only partial, not complete, partial dissociation. Partial. For example, if you consider any weak acids or a weak base, weak acids or weak bases like acetic acid, CH3COOH, it undergo only partial dissociation, gives or produces ions, acetate and H plus ions. Similarly, strong electrolytes, it conduct electricity to a maximum extent, whereas weak electrolytes, it can conduct electricity to a smaller extent because it will undergo only partial dissociation. The number of ions produced in a solution is less, therefore conduction is less. Okay, now coming to the electrolytic conductors again. What are electrolytic conductors? Electrolytic conductors are the substances, here the conduction is mainly due to the flow of ions. Okay, now what are the factors which depends or which affects the electrolytic conductance? That we have to discuss. What are the factors? Factors which affects what? Electrolytic conductance. Okay. Factors which affects electrolytic conductance. Factors which affects electrolytic conductance. First one, nature of the electrolyte used. Nature of the electrolyte used. The first factor which affects electrolytic conductance, that is nature of the electrolyte. We have two types of electrolytes. One is a strong electrolyte and one more is weak electrolyte. See, if it is a strong electrolyte, then it will undergo complete dissociation, complete again ಆಗ್ತದೆ, ionize ಆಗ್ತದೆ. As a result, the number of ions produced is more or it is increases. That's why because of that the conductance, electrolytic conductance is also increases. It is more. If you consider or if you take weak electrolyte, then what happens? It undergo only partial dissociation, isn't it? So, it will undergo only partial dissociations. As a result, the number of ions produced are less. So, the conductance is also less. So, that is the first factor which depends electrolytic conductance, that is nature of the electrolyte used. Nature of the electrolyte used. The second factor, that is nature of the solvent used. Nature of the solvent. Nature of the solvent and viscosity is its viscosity. Nature of the solvent and its viscosity. See, if you consider, imagine a solvent, mainly depends upon its polarity. Okay, so conductance or electrolytic conductance increases or it is more in case of polar solvent. If you use a polar solvent, if you consider H2O, polar in the sense there is a charge separation. Okay, if H2O, it is a polar solvent. Polar in the sense in H2O both oxygen as well as hydrogen atoms, they are charged, having positive as well as negative charges. So, if we use polar solvent, then the conductance is more. So, we can say the electrolytic conductance depends upon the polarity of the solvent. Greater the or more polar the solvent or greater the polarity of the solvent, more is a conductance. And what about viscosity? Viscosity is nothing but it is the opposition to the flow of what? To the flow of ions. So, if we use any solvent, if its viscosity is more, then what? Then the conduction is less, because viscosity is nothing but the opposition to the flow of ions. So, if you use a highly viscous solvent or a liquid, that means in that case conduction is less. What type of conduction it is? Electrolytic conduction is less. So, the second factor is nature of the solvent and viscosity. Next one, the third point, temperature. Temperature. As we increase the temperature, what happens? The dissociation goes on increases or ionization increases. So, the conductance, electrolytic conductance in the sense, the electrolytic conduction is mainly due to the flow of ions. So, ions galu jaasti movement iddashtu conductance jaasti. So, strong electrolyte, if you use a strong electrolyte, then the conduction is high. If you use a weak electrolyte, conduction is less because there is a less number of ions. The second factor is the nature of the solvent. As the polarity of the solvent increases, the dissociation increases, the number of ions increases, the dissociated ions are increases, nothing but conductance increases. And if the viscosity of the solvent is more, then the conduction is less. Third point, temperature. As we increase the temperature, ionization or a dissociation goes on increases. In other words, electrolytic conductance is also increases. And the last, fourth factor is concentration of the electrolyte. Concentration. Okay, concentration of the electrolyte. So concentration, at a higher concentration, highly concentrated solution, in that case there is a interionic attraction between the ions are present. So because of that, conduction is less. Since the ions are they are held together by a strong interionic attractions, as a result free movement is hindered. In other words, conduction is less. So the fourth factor, the concentration of the electrolyte. As the concentration of the electrolyte increases, interionic interactions is more, therefore conduction is less. So that is about the factors which are responsible for electrolytic conductance. The next is about metallic or electronic conductors. We know that electronic or metallic conductors are the substances which allow the electricity to pass through it, mainly because of the motion or a movement of electrons. Okay. So under that we have factors. There are two factors. So factors affecting metallic or metallic conductance. Factors affecting metallic conductance. Factors affecting metallic conductance. Under that, first one, it depends upon the nature and type of the metal used. Nature and type of the metal, nature and structure of the metal. Okay. Nature and structure of the metal. And the second point is, it depends upon the number of valence electrons. So number of valence electrons. And the third point, temperature. So there are three factors which are responsible or which affects the metallic conductance. The first one is nature and structure of the metal. Depending upon the nature, that means whether the metal is electropositive metals or not. So I ಜಾಸ್ತಿ electropositive ಅಂತ ಹೇಳಿದ್ರೆ electrons ಅನ್ನು ಬೇಗ ಬಿಟ್ಕೊಡುವಂತ metals ಅಥವಾ ಅಲ್ವಾ. So depending upon the nature as well as the structure of the metal, metallic conductance, okay, depending upon the nature and structure of the metal, whether we can predict whether the metallic conductance is more or less. Next is the number of valence electrons present in an atom, metal atom, especially in a metal atom, depending upon the electrons which are present in the outer shell. So last shell aliruvanta electrons ina mele metallic conductance enagtade depend agtade, because the valence shell which is far away from the nucleus, so there will be a less interaction between the nucleus and those electrons. So one can easily, or that those electrons can easily participate in the solutions or can easily move in the solution. So depending upon the number of valence electrons present in a metal atom, we can identify the extent of metallic conductance. And the last one is temperature. As the temperature increases, metallic conductance or electrolytic conductance decreases. So you can, one homework for you, try to write the differences between these two conductors, okay, electrolytic conductors as well as metallic conductors. Clear? Okay. Now, we shall discuss some more important terms in this chapter, that is, so now we have to discuss about conductance of electrolytic solutions. What is this conductance? So conductance of electrolytic solution. Conductance of electrolytic solution. So before that, let us understand the meaning of a resistance. So what is this resistance of a solution? Okay, so each and every substance, they offer some kind of opposition to the flow of current or to the flow of electricity. So now, so the exact value of resistance can be determined by using Ohm's law. Okay, so now if E, capital letter E, is the voltage or potential difference between the two ends of a conductor. Okay, let us assume if E is the voltage or a potential difference between the two ends of the conductor and I is the current flowing through the circuit, then the resistance can be given by resistance R is equal to, we have Ohm's law. This is Ohm's law. You have studied it in physics class. So instead of V, I'll write here, it is E, voltage I into R. That means the voltage or a potential difference between the two ends of a conductor, it is directly proportional to the current as well as the resistance. So I'll write resistance as E by I. Okay. Now, let us define resistance of a solution. So this is a general meaning of resistance by applying Ohm's law. Now, what is the resistance of a solution? Resistance of solution. Now, we need conductance. So, in order to understand this, we need to know about the resistance of the solution. What is this resistance? On the solution in a resistance and hege. So, the solution, it is taken in a specially designed cell. We should take a solution, any solution, in a specially designed cell called conductivity cell, or in any vessel we have to take what? A solution. Then we have to place electrodes, two electrodes. One is acting as a anode and one more is acting as a cathode. So in between the electrodes we have a solution now. Okay, so the resistance of the solution, I'll define like this. So resistance of the solution, it is directly proportional to the distance between the electrodes or a length of the electrodes, and it is inversely proportional to area of cross section. What I told, see, this is a cell, when a vessel. So inside the vessel we have to take solution and we should connect to electrodes. So now if L, small letter L is the distance between these two electrodes and A is the area of cross section, then the resistance of the solution is directly proportional to length or a distance between the two electrodes, and it is inversely proportional to area of cross section. So now by removing the proportionality sign, I can write like this: R is equal to a constant term called rho into L divided by A, where rho is, it is in Greek word, so where rho is resistivity. So what is rho? It is resistivity, or it is called specific resistance. it as specific resistance. Okay, so where rho is resistivity or specific resistance. Now, what is a SI unit of rho? So we can write rho as rho is equal to R into A divided by L. Here, what is the unit of resistance? So resistance, it is measured in ohms, isn't it? So it is measured in ohms. I'll write ohm, and unit of area, it is meter square divided by length, it is in meters. So we get ohm meter is a unit of rho, resistivity. So what is the unit of resistivity or a SI unit of resistivity is ohm into meter. Now let us define resistivity. See, here we have two important terms. One is a resistance. What is the resistance of a solution? Resistance of a solution, it depends or it is directly proportional to the length or a distance between the electrodes, and it is inversely proportional to area of cross section. So definition you have to study along with the formula. What is the formula? R is equal to rho into L divided by A, and its unit of resistance is ohm. Next comes rho. What is rho? Rho is resistivity or specific resistance. What is the unit? SI unit, it is ohm meter. And write its formula. Formula of resistivity you can write like this. Rho is equal to capital letter R into A divided by L. What is the definition? Definition of resistivity. Definition of rho. Resistivity or a specific resistance. See, in the expression you can see here, rho is equal to R into A by L. If I keep A is equal, if I take area is 1 meter square and length is 1 meter. That means in a solution, if the distance between the electrodes, if it is 1 meter and area of the cross section area is 1 meter square, then what happens if you substitute these values in this expression? What will get? Rho is equal to R. So now you can define resistivity. What is resistivity or a specific resistance? It is a resistance of the solution. Resistivity or specific resistance, it is a resistance of the solution when it is 1 meter long and area of cross section is 1 meter square. Clear? So what is a resistivity or a specific resistance? It is a resistance of the solution when it is 1 meter long and area of cross section is 1 meter square. So here there are important terms. One is the resistance of the solution, its formula and unit. So next is resistivity, or it is called specific resistance. So now we will define conductance. So what is conductance of a solution? So conductance is nothing but it is a capacity of a solution to conduct the electricity. Okay. So conductance it is denoted by the symbol capital letter G. So conductance G, it is a reciprocal of resistance, isn't it? So conductance, it is a reciprocal of resistance. Resistance is more. If the resistance is more, then the conduction is less. Resistance is nothing but kind of opposition. So they are inversely related. Okay. So the conductance, it is a reciprocal of resistance R. And we can define conductance as it is a capacity of a solution to conduct the electricity. It is a capacity of a solution to conduct electricity, and it is a reciprocal of resistance. Now we can write G is equal to, what is R? We have the formula for resistance, that is rho L divided by A. which is equal to A divided by rho into L. Here you can see 1 divided by rho, 1 by resistivity. I'll write like this: G is equal to a small letter K, A by L, where 1 by rho is nothing but K, where K is called kappa, or it is conductivity. It is what? Conductivity, or it is specific conductance. It is specific conductance. Again, it is important. Okay, so conductance is equal to, capital letter G is equal to K kappa into A divided by L, where K is conductivity or specific conductance. Now, what is a unit of conductance? Since it is a reciprocal of resistance, so unit of resistance is ohm. So what is the unit of the conductance then? It is a reciprocal of ohm, that is ohm inverse. Okay. So we have G is equal to, or SI, okay, I'll write like this. Here conductance, it is a reciprocal of resistance, and conductance we can also define it as it is a capacity of a solution to conduct electricity, and where G is equal to 1 by R. Now, unit of conductance. Unit of conductance, since G is equal to 1 by R, it is ohm inverse, or we can say MHO, mho. SI unit is Siemens, very important, Siemens. Symbol is capital letter S. So conductance, it is a reciprocal of resistance, or it is a capacity of the solution to conduct electricity, and the unit of conductance is ohm inverse or mho. SI unit is Siemens, and the unit or the symbol is capital letter S. Now let us define conductivity or specific conductance. So here G is equal to, we have a G is equal to K into A by L if A is equal to 1 meter square and L is equal to 1 meter. Then what happens? G is equal to K or kappa. So what is specific conductance or a conductivity? It is a conductance of a solution when it is 1 meter long and area of cross section is 1 meter square. So what is conductivity or a specific conductance? It is a conductance of a solution when it is 1 meter long and area of cross section is 1 meter square. Okay. Now, what is the unit of K? So, unit of K. So, we have in the formula K is equal to, or we can write G is equal to K into A by L, or G into L divided by A, which is equal to K, where K is conductivity or specific conductance. So the unit of conductance, if you write in a Siemens, I'll write like this: Siemens into meter divided by area meter square, so which is equal to K. So meter, Siemens meter inverse. So Siemens meter inverse. It is a unit of what? Unit of K, conductivity or specific conductance. So we have studied conductance and resistance. So what is conductance? Conductance, it is represented by the symbol capital letter G. It is a capacity of the solution to conduct the electricity, or it is a reciprocal of resistance. What is resistance? Resistance, it is directly proportional to the length and inversely proportional to the area, isn't it? So the unit of resistance is ohm. And what is the resistivity or a specific resistance? It is a resistance of the solution when it is 1 meter long and area of cross section is 1 meter square. So next is a conductance. It is a reciprocal of resistance. What is conductivity or a specific conductance? It is a conductance of a solution when it is 1 meter long and area of cross section is 1 meter square. Okay. So what is the unit of kappa or conductivity? It is a Siemens meter inverse. What is the unit of conductance? It is mho or ohm inverse or Siemens. So this is about conductance, resistance, conductivity and resistivity. So after that we have conductors. Already we discussed about conductors, insulators and semiconductors as well as superconductors. So in terms of based on the conductivity, we can define conductors as these are the substances whose electrical conductivity is very high, whereas insulators, these are the substances whose electrical conductivity is very less, and semiconductors, their electrical conductivity lies in between conductors as well as insulators. Whereas the superconductors, these are the substances, it has a what? Infinite conductivity, or we can say zero resistivity. Superconductors, for example ceramics, they are all examples for superconductors. They have what? They have infinite conductivity and zero resistivity. So in the next class we shall study about the measurement of conductance in solution. So measurement of conductance in ionic solutions. So that we shall discuss in the next class. Thank you.